So here I have a few cylinders, and even this is a cylinder, this candle. And in this video, we will learn how to do magic. Let's see. Okay, so jokes apart, in this video, we will learn how to find the surface area of a cylinder. So this here is a cylinder. So I've made the cylinder out of paper. So this has the curved surface area, this part. So this has a curved surface and also two flat surfaces, which are the ends. So let us try to find out its surface area. Okay. So how do we go about finding the surface area? Well, we'll follow the similar approach as we followed in case of a cuboid. So what we did in that case was we had opened the cuboid into simpler shapes and found the area of those shapes. So I can do some similar um thing with this too. I take a scissor. First of all, I'll remove the top end of the cylinder. Cylinder. So this is the top end. So I hope you can recognize this shape. This is a circle. So yeah, I keep it there. But yeah, before I proceed ahead, I'd like to define the variables that we'll use. So to define any cylinder, we need two measurements. Firstly, the radius of the cylinder. What is the radius of a cylinder? It's the radius of the circle at the base of the cylinder. So this is a circle, or let's take this. This was the base of the cylinder, right? It is here, or even the top. They both are similar. So if I mark the radius of that base as r, so I'd say the radius of the cylinder is r. Then I can define the height of the cylinder. The height of the cylinder is obviously this much. So I can just draw it on this edge, h for height. So this much is the height denoted by h. So yeah, let me now proceed ahead. So that is a bottom end, the bottom face, and I can similarly cut the top end also. So that is the top end, and even that has a radius r. Both are exactly similar, right? You can see that. See, both are overlapping completely, so their area is the same, the radius is the same. Now I can cut the curved surface area. So before we cut this, I'd like to explain one thing. So this is the curved part of the cylinder. So we call this the curved surface area. So I'll keep those two aside, and let's talk about this. So this is a hollow cylinder without the top or the bottom. And if we find out only this surface area, we call that the curved surface area, because this area is the curved. This is the curved part of the cylinder. So let's find the area of the curved surface, or the curved surface area of a cylinder. For that, I'll just cut open the cylinder from its side, and what I find out right now is that, what shape is this? This is a rectangle. This might look like a square, but it could be a rectangle also. Obviously all squares are rectangles, right? So what is this length? So I know this, the breadth of that rectangle is h, or the height of the cylinder, if you see it that way. What is this length? Well, this length is nothing but, if we take, so I'll just label. So to find this area, I need this and this, right? So this is this I know is h. What is this? Well, if I again fold this back, this length becomes the perimeter of the base. What is the perimeter of the base? Well, the base was a circle of radius r. what is the perimeter of a circle? The circumference, and it is given by 2 pi r. So this is the perimeter of the circle, which is given by 2 pi r. So this whole length is 2 pi r. So now I have got both dimensions of the rectangle, the length and the breadth. The length being 2 pi r and the breadth being h, or the height of the cone. To find this area, I simply multiply this with that, and that gives me 2 pi r times h. And this 2 pi r h gives me this surface area. And what is this surface area? Well, this is the curved surface area of the cone. So what is the curved surface area? So CSA for short, curved surface area. Curved surface area of a cone is given by 2 pi r h. Now, if I have to find the total surface area, I need to add the areas of these two circles. What is the area of a circle? The area of a circle is nothing but pi r square, right? Similarly, the area of this circle is pi r square, pi r square, and 2 pi r h. So I can just keep them next to each other. So that is the curved surface area 2 pi r h. To find the total surface area, I need to do 2 pi r square plus 2 pi r h plus another pi r square. Pi r square plus 2 pi r h plus pi r square. If I add all that up, I'll do it on this sheet of paper. So what I get is pi r square plus 2 pi r h plus pi r square. So that is the total surface area of a cylinder. That's one equals to, right? So if I solve that, I get the total surface area equals pi r square plus pi r square, 2 pi r square. So 2 pi r square plus 2 pi r h. This is the total surface area of a cylinder. This being the curved surface area, this being the area of the ends. And to simplify even further, I can take the 2 pi r common, and what I end up getting is, I'll write that here, total surface area equals 2 pi r. So I'll just take that common, right? 2 pi r times r plus h. So if you see, if I open the brackets, I get 2 pi r into r, which is 2 pi r square, and 2 pi r into h, 2 pi r, which gives me 2 pi r h. So that can be written as this. So this is the total surface area of a cone, and if you just had to find the curved surface area, that is simply 2 pi r h. And there you go, the surface area of a cylinder. One small addition that I wish to make is, so in the when we were doing the total surface area of a cuboid, there was some questions where we said we were asked to find the area of both the inside and the outside of the shape. So while doing those questions, all you need to do is apply a bit of mind. So for example, if somebody asks you to find the total surface area, the total curved surface area of both the outside and the inside of a cone, of a cylinder, so you will find this area, multiply that by 2. And if somebody asks you to find the total surface area when the base is there, then find this area, multiply that by 2. And if there's no top, don't add that area. I mean, it's all about applying a bit of mind. You need to visualize this, draw a diagram, and think what all parts do you need to include and what all you need to exclude. Don't simply memorize. Apply your brain, visualize, draw diagrams, and then solve the question. That's it. Bye.